The new U.S. strategy focuses on space exploration in new and unique ways. One being research and development to support future heavy-lift rocket systems that will increase the capability of future exploration and lower operations costs. Two being a technology development and test program that aims to increase the capabilities and reduce the cost of future exploration activities. NASA, working with industry, will build, fly, and test in-orbit key technologies such as automated autonomous rendezvous and docking, closed-loop life support systems, in-orbit propellant transfer, and advanced in-space propulsion, so that our future human and robotic exploration missions are both highly capable and affordable.
We should explore the surface of the moon because there is less guessing with more information. We could learn what minerals create the surface or under the surface of the moon. Are these minerals possibly useful as a natural resource for people on Earth? We could also learn about the weather. The winds or gravitational pulls on the moon's surface could help predict our weather on Earth. We know the moon affects the ocean tides. Are there clues on the surface of the moon that could tell us other pressures that the moon's pull creates for us? There are still more information on the moon. That's why we should continue lunar exploration.
The Earth is tilted at an angle of 23 degrees and spins around like this day and night. The moon is tilted over just 1 degree, so if there's a crater on the top and the sun is right here, the sun will always hit that crater. That is called a peak of eternal light. So a peak of eternal light would be a good central base from which to begin our lunar activities. It would provide a source of solar power for exploration, astronomical observations, life science experiments, and the investigation of possible water in the dark craters.
Water was found on the south pole of the moon. The target crater, Savius, has a temperature on its floor of 230 Celsius, cold enough to store ice. The idea is that over millions of years, comet impacts and other events have brought water to the moon. Most of it goes away over time, but if any happens to accumulate at the bottom of the space craters at the pole, where the sun never hits, it can stay frozen in shadow. It is called water ice. So now we have water on the moon if we ever run out when we are on the moon.
We should go to the moon for helium-3 because there is plenty of it on the moon and there's scarcely any on Earth. Scientists believe that there are about 1 million tons of helium-3 on the moon, enough to power the world for thousands of years.